Hello, good morning. I'm going to show you some results on social conflicts which has been obtained by using statistical physics and Monte Carlo simulation. This work has been done in collaboration with Myron Kaufman and Sandra Kaufman of Cleveland State University. The outline of my talk is shown here. I will show how to use statistical physics to study social phenomena. For illustration, I will consider the problem of social conflicts and show results using the time-dependent mean field theory. I show next the result obtained by Monte Carlo simulation for those problems. Results for two-group conflicts and three-group conflicts are shown before the conclusion. Statistical physics study system of many interacting particles. Collective behavior and phase transition are popular domains of statistical physics. Spin models are used to describe particles, but the spins are not always a spin. In magnetism, they can represent particle state as well. In social physics, a spin can represent opinion of a person. For example, in a problem where yes or no are requested as opinion, we can define S equal to 1 for yes and S equal to -1 for no. If we need yes, no, and without opinion, then we can take S equal to +1, -1, and 0. Now, in a problem where a person can have 5 degrees of opinion from very negative altitude to very positive altitude, we can define S equal -2, -1, 0, 1, and 2. Of course, when opinion is continuous, is not yes, not no, we can use continuous variable, and in that case we can use continuous spin models. So, according to the problem treated, one can choose an appropriate spin model. For example, the Ising spin model, the Q-state Bose model, and the continuous spin models like XY or Heisenberg spins. We can also choose quantum spin models for some complicated problems. The spins can represent human beings in a society because his or her opinion can be quantized on a scale. His or her opinion can be affected by interaction with the other and with the social crisis, social ambience, etc. Note that in statistical physics, particularities of individuals are washed away in the averaging. Only common dominant characteristics remain at the end. That's why in opinion surveys on a problem, we find only a few main opinions among thousands of people interrogated on the subject. Note also that what determines opinion and action of a human being is due to his background on education, on psychology, on philosophy, on politics, not by his human uniqueness. Let me talk about the interaction between individuals. The interaction between two individuals, Si and Sj, is given by this formula, where is the energy and J is the interaction strength. We will take the following convention. If J is positive, there is a stable state of two individuals is when they have the same sign, the same opinion, namely the same value of S. And this will yield E negative. When the individuals do not have the same sign, then E is positive. The situation between the two individuals is a conflict. The value of E expressed, therefore, the degree of conflict. We can generalize this into the interaction between individuals in a society. Note that, unlike in physics, Jij can be different from Ji. It means there is no symmetry necessary in the social problems. I introduce now the social temperature T. Social temperature T is a parameter which expresses the degree of social perturbation or social ambience or social pressure. T acts therefore on each individual as follows. If T equals 0, it means no perturbation. Each individual is at his or her most stable state. At a finite T, the individual will feel some perturbation, so T acts as a disordering factor. So, as you see, the individual state depends on the ratio T, J over T. J favors collective ordering, while T represents social perturbation. As I said earlier, in the process of time average and space average over individual states, only the common characteristic will remain at the end in the macroscopic properties. Now, I describe a model of two groups in conflict by this picture. There are two layers. The upper layers are the group 1 and the lower layer is group 2. And the interaction between individuals in the same layer are J1 and J2 respectively, and the interaction between the group are given by K12 and K21. As I said earlier, K12 is not necessarily equal to K21. I write here the time-dependent mean field equation. Note that the state of an individual A at the time t plus 1 depends on the people of his group, and the action of the other group B at the earlier time t. Here we use the reduced notation. J is in fact J over KBT. K is K over KBT. T is the temperature, social temperature I introduced earlier. In this equation, MA and MB are the maximum value of SA and SB. I will not enter into details of the calculation. I give here the mean field equation, where B is the prevalent function. We solve these equations self-consistently, and the result I show in the next slide. Depending on the values of J, K, and T, we can have different behaviors for SA and SB with time evolution. The first curve here shows the case where we have a very high social temperature. And the second curve is the curve obtained by a lower temperature, where we can see the oscillation during the time. And the period of this oscillation can be calculated by this formula. And lambda here are just the eigenvalues of the mean field equation. Let me show now a concrete application of our calculation. The Brexit survey between October 2015 and June 2016 show the oscillation of pro and con. The lower curve is our calculation, which shows also the oscillation of the two positions. It is obvious that if the referendum takes place at another time, another date, the result would be different. The second example is the American election in 2016. Our curve shows the crossing of the two curves of Democrat and Republican voter intention by choosing appropriate interaction between the two parties. We can use Monte Carlo simulation to study the present model. The results we obtain from the simulation are in agreement with the mean field calculation I just showed in the previous slides. In this slide, I show you the result of three regions of social temperatures. The first one is the low T, where we can see that each party keep their own stance. The second curve shows the curve we obtain in the critical regions of T. For example, during the period of election, the period of crisis, and so on. We see oscillations of the stance with time evolution. And the last curve shows the result in the highly disordered region. We can see that the change of position is very frequent and chaotic. Let me show briefly now the case of three-group conflicts. This case can be applied to Serbia, Herzegovina, Croatia crisis in 2018. I show here the curve at high T, namely in the very unstable region. You see that all initial conditions of S1, S2, S3 lead to the same fixed point, namely an attractor, as you see on the curve on the right. I show on this slide two regions of lower temperatures. The first line shows the intermediate region of T, where we observe oscillation, permanent oscillation, and instead of a fixed point, we have an attractor line, as you see on the right. And the second line shows the low T region. You see that the attractor line is broken into discontinuous line, and you have a phenomena of synchronization. I give here the references of the works that I have presented in this talk. The first one is the dynamics of two groups conflicts, and the second one is the case of three group dynamics. So you will see there the detail of the calculation and also a lot of discussion on the how to use statistical physics for social phenomena. As a conclusion, I list here some ideas for future developments on social conflict studies. Of course, we can change the nature of interaction, the spin model, and so on. I emphasize that the mean field theory can treat simple interaction mechanism, but it gives a very clear pictures, physical pictures of the result. Monte Carlo simulations are complementary. It can treat the very complicated case, like the case I show on the right of the slide. And the two methods are very useful for social studies. I take the opportunity of this talk to introduce you to my book on statistical physics, where you can find lectures, problems with solution, and many applications in condensed matter physics. Thank you very much for your attention.